In the second part of the video, I showed you how to align the stack and save it. In this part of the video, I will show you the mask analysis to get the X-ray absorption spectra from the region of interest of your sample. So for that, we're going to click on axis 2000 icon here, and this window will pop up, and you're going to click on one of these buffers. These are called buffers, and you'll get the blank buffer here, and load the aligned stack. Click on the stacks. You can see here analyze, go to the axis binary, click on that, and this window will pop up. Now click on aligned stack, which is 75 ALR, and click open, and this will ask you to read an alignment file. Say no. Energies out of order sort window will pop up. Then again say no, don't press S. Then this small window will pop up, and you can get rid of it just pressing enter key on your computer. This is the aligned stack of the nanowire. So maximize it. So before doing the mask analysis, we have to get the optical density. So these images are raster scanned, which means you do the scanning along the X, Y, Z axis, and Z axis is the optical density, which is the logarithmic ratio of I0, which corresponds to the region where there is no sample, which is this, and I, which is the intensity from the sample, in this case from the nanowire. So I will show you how to get the optical density now. So you can see here I0, and you are going to click on region. So this small window will pop up. So leave it as it is. Now you are going to click on the I0, which means the region where there is no sample. So I'm going to click like this. So this is the region where there is no sample. Then I'm going to right click on this region. Okay, it is going to be filled with the black color. So after this, you can see here this accept region and reject region on this small window is activated. So I'm going to select the accept region. That's good. Now I have to select the region where there is sample, in this case the nanowire. So here you can see the I. So again, same thing, click on the region. So this small window will pop up. You can see the deactivated accept region and the reject region. So you are going to click on the nanowire to select the region. Okay, now right click. You can see this accept region and reject region in this small wire is activated. So say accept region. Okay, now we have to get the optical density. If you can see here, you can see the small tab which corresponding to the optical density, and you can see here the description below the cursor, convert transmission region to OD. So I'm going to click on that, You can see here I got the optical density. So after this I'm going to save it. So you can see here the file name which corresponding to the aligned stack 75 ALR. Now I'm going to save this optical density data. So you have to click on that, then just type OD which corresponding to optical density. You can see here many tabs which are deactivated. I can activate it by just pressing the enter on your keyboard. You can see it is activated now. Now we have to save it this in the NCB format. So you can see here stack.ncb. So click on that. The small window will pop up. You can get rid of it by pressing the enter on your keyboard. Okay, now the stack ncb file is saved. So in the next step, I will minimize this window. Now we have to align this optical density data or the stack again using the Jacobson analysis software. I'm going to click on again I will bring it here, Jacobson analysis software, and I'm going to click on that. So this window will pop up. You are going to load the optical density file or the stack file. You can see here we have done it before. So you can see here read stack file. Go to the computer. I will load the optical density data or the file, stack file. You can see here 75 ALR OD, that's your optical density file. So just open it. We are going to align it again so that we get high quality data at the end. So go to file, you have done it before, and click on align stack. This window will pop up, and click on constant reference image and select the first image and start aligning. You can see these are again misaligned. Then save it, then align stack again. Do it until you get both the lines merged. So again, constant reference image, click on the first image, start aligning. Now it is better, and do it again. Okay, done. Save it. Now save this file again. You can save this to the, so to do that, go to save stack file. We have done it previously, and click on axis.ncb, and we are going to save it in the same folder to avoid multiple files. So click on that, the same old file, then click open, which means you are saving the data. After aligning the optical density stack, we will again go back to the Axis 2000 software, which is here. I'm going to load the aligned optical density file. Which is here. No, just press enter. Those windows will go away. You can see here the aligned optical density stack. So before doing the mask analysis, we have to generate an average stack. So if you can see here, this tab which corresponds to average stack. So it will essentially averages all the data, all the images in that particular stack, or in that particular range. So click on that. So this small window will pop up. So this is the buffers that is here. So I will put this in the second buffer. Okay, I will call this small window will pop up. I will call this file as avg, which is average stack. Then press open. So you can just click enter. It will go away. Now we have to generate mask. To do that, go to images tab. Then you can see here generate mask. There are two options, threshold and manual. I will select threshold. In that I will select histogram. This small window will pop up. I want only the region mask from this particular region of the nanowire. So I just select it. Okay, it looks good. You can vary. You can just move the cursor, so you can see the variation in the intensity, variation in the region as well, the color mapping. And I'll just select region which is merely from the nanowire. Okay, looks good now. So click on save ROI. So this mask will be saved. I will call it as full mask because I have chosen full region of the nanowire. Then click on open, which means you are saving the data. Now go back to this front panel and click on read. Go to images, then you can see here ROI, and go to the Axis 2000 stack. Click on that. Then you can see the full mask, the file just now I saved. I'm going to click on that. I'm going to open it. Okay, you can see here. So if you don't want the final X-ray spectrum from the full region of the nanowire, then if you want the final X-ray spectrum from the full region of the nanowire, you can stop it and you can go back to the optical density stack. But if you want the spectra from particular region of the nanowire, let us say from this particular region of the nanowire, from this region, so I'm going to delete the other region. So to do that, go to images, then select delete region, that is here. Click on that. You can see here this small window that will pop up. You have several options here: polygon, point, rectangle, circle. So I use polygon because I'm going to choose a bit larger area. So I will select this whole region area. Okay, after that, you can see here the remove. Click on that. You are going to remove that particular region of the nanowire from that mask. So click done. Okay, this small window will pop up. Just press enter on your keyboard, it will go away. So this you can see here all the regions were wiped off, but you can see here there are some contribution from these small regions, so I'm going to remove it. Do the same thing again. Images, delete region, and this small window will pop up. So this time I will select a point because I want only the small regions. So I'm just going to click on those things. Just click on those regions using your mouse, and here as well. And here as well. So then click on remove. Done. Press enter. Yeah. There is still some contribution here. I'm again going to do the same thing. Delete region. Select a point. Then remove it. Done. Okay, now it looks better. So after this, again you have to generate mask from this region of the nanowire. So click on images, go to the generate mask, go to the threshold, histogram. You can see here it's good. So save this mask again. Save. So I will save this region. I will save this as region 1 of the nanowire. Then open. Okay, so it is saved. Now I'm going to minimize this window. Again, I'm going to load the optical density stacks. For that, you need to go to stacks, analyze, axis binary. Then here is the, no, you have done it before, so just repeat it. Okay, here is your optical density stack, and maximize it. And you can clearly see here the ROI tab here, and you are going to click on that. Then you will click on region 1. I want the final spectra from that particular region. Okay, that's good. Click on that, then open it. Okay, so you can see here this is the final X-ray spectrum from this particular region of the nanowire. But here both the stacks are combined, which means it has both left and right circularly polarized light, but we want them to separate. We need separate spectra from both circularly polarized, both left and right circularly polarized light. I will stop here, and in the next video I will show you how to get the left and the X-ray. This is manganese LH spectra. Therefore, in the next video I will show you how to get the final manganese LH spectra from LCP and RCP separately.